Welcome to the lecture of the tacheometry. That is your fourth lecture, right? Today we are going to see what are the additive constants and what are the multiplying constants, and how can we reduce the additive constant. What are its values? And we'll see the equations to find out the horizontal distance, right? We say that tacheometry is used for calculating the horizontal distance as well as the elevations. So we know how to calculate the elevations, like normally how we do in the case of theodolite, with the help of the staff we do it, right? Same thing, same way we do here, but calculating of distances is something different. We'll study here in this class. We'll be determining the tacheometric constants. Fixed hair method of the stadia system will be studying here, right? So determination of stadia hair. This is how the telescope works, right? The image that you see at AB is inverted at your inner eyes, right? So the distance between the eye is this eye, right? This is eye, and that is eye. It is called as stadia interval. The object is a glass. F is a focal length, right? U is the distance between the lens to the object, and V is the distance between the eye and the object, right? S is a staff intercept. What is stadia interval and the staff intercept? Stadia interval is a distance between the two small crosshairs that are there in the, those are called as stadia hairs, right? So staff intercept is a difference between the two readings taken with respect to the stadia hairs, right? Distance of a stadia interval is different and staff intercept is different. Staff intercept is distance at which we place the staff and take the readings of the upper and lower crosshairs, right? That is S1 and S2. You can get S by minusing it, right? By difference of those two, will get the staff intercept, right? D is the distance from the F is the focal length of the objective. This is your focal length, F, small f. D is the horizontal distance from the optical center of the objective to the vertical axis of the tacheometry. It is the horizontal distance from the object to the vertical axis of the tacheometry. Small d, where is small d? It is the distance between the point G to the glass. G point is where the object forms, right? The point where the object forms in the image. F into I, right? It is your focal length of the objective divided by the stadia interval, will give us the multiplying constant, that is K, small f upon I, right? Small f upon I. Next is C, F plus D, right? F plus D will give the additive constant, that is C. We will not go into the deep of the derivation of its, right? Just understand it. K is 50 to 200, is in a range of the multiplying constant is in the range of 50 to 200, right? And C is 0.6 to 0.3 in external focusing telescope, right? Right, additive constant is 0.6 to 0.3 in the external focusing telescope. C is 0.08 to 0.2 in case of the internal focusing telescope. If you see, internal focusing telescope has a lesser additive constant. So to make this, right, to make this value to 0, make the additive constant to be 0, what we do, we use analytical lens. That analytical lens will reduce this additive constant to 0. What makes, if they ask the question, what makes the additive constant 0, that is analytical lens, right? This is our k is equal to f upon I, that is focal length of the objective and distance between the focal length and the object glass, that is called plus f t. So distance can be calculated as k into s plus c, right? F upon I is what? Is equal to k. So it is d is equal to ks plus c, right? It is ks plus c. F upon I is nothing but it is k. So we are just placing k. We are removing f upon I and we are just keeping it a to make it simple. This how to calculate the distance? Just multiply with the multiplying constant is given to you every time, and additional constant is 0, right? If additive constant is given, you have to take it, right? If not, it will be 0. Ks plus c. S is what? S is your staff intercept. Whatever the two readings that you get, right, above, from the above crosshair and the below crosshairs, difference of those two will give you the staff intercept, right? You multiply and you will get the distance of the object with respect to the station point. So the methods of stadia are, in the tachyometry survey you have two methods, that is stadia method and non-stadia method. In the stadia method you have fixed hair method and movable hair method. So if it is a movable hair method, means hairs crosshairs may be moved depending upon the requirements, right? So where the S will not be constant. In the machine or in a theodolite or a tacheometry, the I, if I is constant, then it is called as fixed hair stadia method. If it is movable, if you can change it, then it is called as movable hair method, right? So we have only fixed hair method. We have only fixed hair method. It is the most prevalent method of tachyometric survey. In this method, the telescope of the theodolite is equipped with two additional crosshairs, right, because it is tachyometry, and one above and the other is below the main horizontal at an equal distance. Right, as I said, if this is your main crosshairs and this is your two small crosshairs, which is above, one is above and one is below. So this distance, it is fixed. I suppose it is 0.25, right? It is 0.25. Then it is 0.25. It is so it is fixed, right? You can't change it. So in that case, it is called as fixed hair method. These additional crosshairs are known as stadia hairs. The additional crosshairs are called as stadia hairs. In this method, the stadia hairs is kept at a fixed interval, and the staff interval or the staff intercept on the staff intercept depends upon the distance between the instrument and the staff. The S will goes on varying because as the distance between the object and the station increases or decreases, the S varies, right? How it will vary, we will see in the next slide. Hence, in the fixed method, the staff intercept and the vertical angle are measured to calculate the horizontal distance and the difference in the elevation. Can you see in this image? When the station is at, or the theodolite or a tacheometry is at station O, right? And O1 it is your telescope. You keep the staff at A, right? You can see the markings of the, you can see the line, the imaginary line that is passing through the staff, right? At the first point A, you can see the above and the below crosshairs, and the main crosshair is the center, and it will be fixed. It will be the same for all, but the above and the below will be changing because it will be diverging outwards, right? It will diverging outwards. It will be going increasing. If you see the S1 upper value, upper reading, and S2's upper value, there is a difference. S2's upper value will be higher than the S1's higher value, upper value, right? So depending upon that, the distance will vary, and the difference between the two staff reading is called a staff intercept. Here there are three staff intercept. It is S1, S2, and S3. See, these are how you can see the. You see here the various types of crosshair, how they are given. Mostly this is a type, first type, which you see all over. Sometimes it might be different, right? Depending upon the type of company which manufactures it, it varies, right? These are the way they show the tacheometry stadia hairs. In the next class, we will see how to calculate the values when the problem, we will solve the problems in the next class, right?